Right. Salam and good afternoon. Can you hear me?
Yes,
Yes,
Walaikum
Prof.
Salam.
Very
Can
good.
hear you.
So we can begin. Slides already uploaded by Dr. Yap in your author, so you can refer there if you like. And I hope that you have watched the two recordings yesterday during the class time, and that so we do not need to go through the introduction today for module three. And more importantly, is that you have digested on your task or the assignment for module three and on how to score. So it shouldn't be a burden. It is a simple basic research design or your respective work, whether it's a master's or PhD level. And uh, as I said, the maximum 2 pages. If you make it in one page, keep it to just one page to do. Um, no fixed format for it. You want to write in words or you want to put it in infographic or whatsoever is up to you as long as the information required presented. And look at the rubric if you want to score. So, and I cannot emphasize enough on punctuality of submission. All right. I believe that Dr. Yak would open up the respective folders for you to submit your work. And I think it would be best that you submit per your faculty so that it's easier to track who has submitted and not. As I said, learning from my painful lesson last semester when students submit late and they claim that their work is lost or things like that. So it's a he say, she say, they say, and that shouldn't be happening. All right. Especially you guys, your science and engineering, technology students doing research should be a lot more organized and a lot more meticulous about time management, I presume. So please, it is a good 3 weeks for a simple task. There's really no reason to not submit on time. If you reckon that, I understand that perhaps many of you here are working people. I understand and respect that. It's just that you're signed up for the program, and whether you're doing it as part-time or full-time yet working full-time as well, you got to make time for it. So my simple advice is that it's a simple task. Do it within the week and have it sorted out. Because if you KIV, then every module there'll be more work piling up, and you may just have forgotten about it, or last minute something may happen. We don't know, and we are late in submission, or we just totally forgotten about it, and we don't submit until the very end. When the marks are submitted and the grades are given, then that is not very appropriate anymore. Okay, any questions before we start? Anything you want to ask before we proceed? You know, one thing about online class is that when nobody answers you, you feel like you're talking by yourself, which is a bit weird. I appreciate it. If you could just say yes or things. I don't insist that you turn on your video. It's all right. Or at least um, say yes or something like that, so that I wouldn't think that I'm alone in here, or that I'm already gone offline and I didn't realize that. Okay, so if not, then shall pull up my slides and we can begin the. I wouldn't even think of this as a lecture. It's more like a sharing session, right? So hoping that the research methodology um, session would be helpful to you at the beginning of your um, respective studies, that you can have an idea of how to design a research methodology. All right. Okay. Okay. So here we go. Yeah, and the correct class, right? It's research methodology module three, and specifically for the science and technology students, and engineering students, obviously. So I'm from the Faculty of Engineering Technology. My background is civil engineering, to be more specific, in geotechnical engineering. Um, um, this is part and parcel of what we as researchers, as research students, we have to go through. Um, so let's see what we can learn from here, today's sharing session here. So I said the front bit, I'm going to go through them very quickly, or in fact, I'll probably skip them because you have seen the recordings. Essentially, I said research is something that we can say that we are moving in the unknown to a certain extent, but of course, standards as our guidelines, previous work literature as our guidance, and so on and so forth. But really, if we knew what we were doing, and it wouldn't be called research. Because research comes from two words, right? Search and re, meaning that I search and I search again. So there's always something unknown, some question marks, and some question that we would like to find some answers to. All right. And as you've seen in the summary video that research methodology essentially is putting our research into a logical sequence, right? We may have it on how we want to do it. Yeah, first I do some background reading, and then I come up with my proposal, and then I have a Gantt chart, and I do my research. It, in a general way, the outline is such, yes, you're right. But if we do not plan our research work carefully, especially for those who are embarking on the 3 year or more PhD program, which is a longer term thing compared to a master, and a bigger scale, deeper scope or wider scope. And you may find yourself along the way a bit lost, or not quite sure now whether the direction is as you plan. When we say as we plan, meaning that it's per our original problem statement and objectives. It is not a good idea to keep changing our problem statement and objectives along the way, because every time we change it, we are either doing a detour, or we are uh, digressing, diverging. And as we know, as Einstein said, the nearest distance between 2 points is a straight line. So the more detours we make, the more diversion we make, digression we make, then the longer time it take us. And we try to keep our research period for masters or PhD within plan. I'm not saying shorter or longer. I'm saying within plan. If we are planning for 3 years, and to put injury down half a year, then it should be 3.5 years and not dragging on to 15 years, for example, right? Unless due to unforeseen circumstances and things are put, it shouldn't be dragged on that long, all right? And we have gone through this, saying that basically it is on managing our project. You always run through the typical process of planning, uh, checking our resources, checking whether um, the feasibility of things, meaning that do we have enough facilities for doing? Is there are the materials available? The people that we are going to seek help from, experts in statistics, for instance, or some scientists in the area where we are not going to study about it, but we need their help to give us information. Or if our work involve field measurement, then our coordination with the field people and things like that. So these are some of the areas that in planning our research right at the beginning, doing our research design, uh, outlining our research methodology, we got to take into consideration. All right. You note in this slide that I put in number 7, collaboration as well, because I think these days most of the research projects, even at master's and PhD level, are one, multidiscipline or cross-discipline, two, involving outside people. When I say outside people, usually it is involving one, industry, meaning that it could be an industry problem, or we are borrowing the equipment, or they are having giving inputs in terms of their expertise, experience, so on and so forth. Two, we are using their material. It's an industrial problem in science that we are trying to resolve their problems, hence using their technology, their materials. And number three, it could be a case of our co-supervisor is from outside the university. That also that can be considered kind of collaboration, because it could be a case where, say, for instance, your co-supervisor is from UMPSA, and the industry project, the industry problem is actually in Pahang, for instance, and the contact of with the industry is with via your co-supervisor in your PSA. Of course, then your supervisor and your co-supervisor must have been the colleagues or must have friends, likely to be at least people who have worked together before. That's why he or she is being appointed as your co-supervisor there. And some of you may have projects where you have project advisor, meaning that a third party is coming in from outside as your guide, but not as a supervisor, but as an advisor, especially those who are experts, practitioners out there in the industry. Okay. And we also have looked through this about the frameworks coming to play, the theoretical framework, it could be simulation, it could be experimental. So you notice that these three main frameworks are the ones that are being incited again, mentioned again in your assignment tray. So really, kids, I'm sorry, I used to, in undergraduate class, I want to make you feel comfortable. I used to call them kids. And so you are most, many of you here most probably are stalwarts in the industry. So yeah, the best I can say, your students, you're no longer kids here. So adult learners and all. Okay, so what I'm trying to say here is that you can see from the slide so far that your assignment doesn't it's not something that is going beyond what is being shared these 2 days, whether it's online or offline. And that to answer or rather to score for this particular assignment entry, just follow the rubric and the references are there in your slides. Okay. Mm. So not necessarily that you have all three components. The first one definitely everybody must have it, the theoretical part. For depending on the scope of the study and the nature of your investigation, your work may be purely experimental, meaning that it's totally lab based, or like what I myself did for my doctoral work. And but some of you may have a few measurements, and some may involve simulations with softwares and all. So then it could comprise of all three frameworks. So it really varies from people to people. So in your case, if you are going to put in your assignment the real case, meaning that your own project, and it doesn't have simulation, for instance, by all means, leave out the simulation. Just take a make note, put down a note there that your work is such, and it doesn't have any simulation work involved, right? So you don't have to have all three components. The best case scenario is that when you answer your assignment three, use your own project, all right? Because I believe that you're all in your year one, sem one at the beginning of your research journey. So it's a good time really to undertake a research methodology class, at least to have a exposure, all right? And for those who have done it before, for instance, those who are in doing their PhD, you have seen this before in your masters, and take it as just as a refresher course so that you are minded of how to do it in a structured and organized way to save time and perhaps to save cost in a way. Okay. And then we zoom in onto quantitative and qualitative data collection and analysis. So we're going to dive deeper into it later on, but very quickly, essentially, the quantitatives refer to the numbers and the qualitative are more towards stuff that abstract or descriptive. And you can also say that the qualitative are more commonly used among the non-engineering people. But then again, as I said, these things are all having dissolving borders and blurring of boundaries. So engineering people could be doing some qualitative analysis and vice versa by the social sciences people. As all the quantitative and analytical approaches can see down here, I believe that those who are using a lot of statistical softwares, you know better than me on this matter. All right. Okay, okay. And also you could be doing the mixed method approach and I think this is interesting, and I think a lot of the research design these days, even in the engineering faculty and the sciences faculty, are going towards this, meaning that at one in a small part, right, of the chapter four, when I talk about the results and discussion, they address the sustainable development, for instance, they address ESG components, for instance, to show that to put the very highly technical piece of research into context with the global issues, right? Especially with SDGs until 2030 when they expire. There is still room, there's still time, 1 or 2 years more before the new framework is being tabled in the United Nations. So I think the words are going around that by the 2027 we should have some kind of a draft framework coming out to replace the SDGs. All right, just like the SDGs replaced the Millennium Goals 15 years ago. All right. Okay, and we have seen this, talked about this in the recording, so we need not go any deeper about it. And when we zoom into data analysis, then the long and short of it is that regardless of what the data look like, whether they're numbers or they are statement forms or interviews, surveys, we need to make sure that they can be presented in a manner that is easily followed by people. We haven't come to understanding it, just following through what you're trying to explain and then leading to understanding. So there's no point of gathering a lot of good data, good information, and running through high level or advanced analysis. But in the end, we fail to convey the message, to present the message, to present the findings, to share the conclusions, the discussions in a way that is coherent, structured, and a way that people can understand. Right? So the end game is making other people understand. And the first people you need to make understand your work are your examiners. All right. Along the way, you have progress, presentation progress, assessment. Some faculties do it every semester via presentation. Some faculty do it alternate semesters, but it doesn't matter. But every semester, you have some kind of evaluation. The list is by your own supervisor. So it is necessary to make sure that your work builds up in a timely manner on the timeline, mean that in a university system, then it is by semester, right? But if you are working out there as a researcher, then it is just a case of you managing your time, putting in the starting and ending date and work within the time frame that you have. So this will be a good practice for you to run your own program or to run your own project, manage it in terms of time, money, resources, all sorts, and make sure that it is on time, not just at the end, but progressively per your milestones. So you see later on in research methodology, you always end up with the Gantt chart, a flowchart, a Gantt chart, flowchart, a Gantt chart, and the flowchart is really a summary or skeleton, if you like, of your research methodology. So if we have a poorly planned research methodology or a misaligned research methodology, and it is very difficult to expect our flowchart to be correct or guiding one, all right? And let alone the Gantt chart or the timeline or the schedule that we actually create based on our flowchart, right? So you see the domino effect of things and how one leads to another in planning research, all right? A simple example here put in for you saying that if I just want to determine the kids' achievement in mathematics in a primary school, for example. So just at the first glance, you will see that, yeah, I can already segregate my sample, which are the kids, into a category of age, gender, grade level, and the mathematical grades that they are, mathematics grades that they are undertaking for that particular year that I want to analyze the results. And that is from there, I will identify the parameters, which I further divide into the variables and the constants, and to see what kind of approach I'll need to carry out to make sure that the questions are being answered. All right. So simple thing like trying to analyze the kids' performance in mathematics or any subjects in school is already a kind of small research. So we have been doing it all the time. So do not panic. It's like, wow, this is the research, it's PhD master's is half. No, you have been doing it, especially thinking that you have at least done your FYP respectively. All right. If you're into your doctoral study, unless you are a fast track student, you have done your master. So everybody would have at least a bachelor. If you are an uphill student, mean that you have not done your master's or bachelor, then I believe along the way, even at diploma level, you have done some kind of research work. And in your years of working experience, I'm sure you'll be exposed to research processes and research experience that have been accumulated there. All right. And The goal of doing the research is obviously trying to make sense of the data that we have acquired and to come up with some actionable insights. We want results, test results, collected result data, basically, that we analyze them to put them. Why do you do analysis? You want your data to be presented in a way that makes sense. All right, otherwise they're all over the place. Why you want them to make sense? Because you want to be able to look at them and find a certain pattern. All right, a certain pattern in there. Is it going up, going down, scattered? What? Is it time dependent, temperature dependent, people dependent? What? All right. Why? Because at the end of it, whether I'm researching on soil, whether I'm researching on people's behavior, whether I'm researching on passengers' preference for commuter transportation, whether I'm researching on the school performance in terms of mathematics and science, blah, blah, blah. At the end of it is that I want to come up with some conclusion which goes back to address my problem statement. Why? Why is that a problem statement? Because I want to propose some positive action plan, some actionable insight from my research will contribute to that. Otherwise, it will just be uh, in Malaysia, because I believe that international students here, we call it simbang kosong, meaning that it's just chit-chatting for fun. All right? We chit-chat at the beginning, we chit-chat in the middle, we chit-chat right up to the end without any conclusion, without any action plan. So that is not research, that is just a conversation, a leisure conversation. All right. So that is something that we must avoid when we are doing a research here. And now, if we zoom in to look at the need of doing the research, as quantitative research means we need look at data which have been collected, and those answers will need to be analyzed in a way that is accepted by everybody, whether the data is being collected and appraised in Malaysia, in Zimbabwe, in China, in Japan, wherever, because we are referring to the same standard. Say, I do a project at the upfront here that my examples will be mainly civil engineering, maybe even geotechnical engineering, because I do not want to overstep my line and talk about other fields which I am totally unfamiliar with and say nonsense there. Okay, but the gist of it is the same. So if I were to follow the standard of, say, EC2 for structural design, then the whole world looking at the Eurocode will be looking at the same, referring to the same standard when they're doing that particular piece of analysis. Same here for soil mechanics, and I'm talking about, say, an odometer test. I'm talking about BS 1377, then everybody will be looking at the same standard there, in the British standard reference there. All right, same for ASTM and ASE, all the references that you may be looking at. All right. And the methodology is reputable not because it's famous, but because it's established. Not all test methods approaches are being standardized yet, meaning that different countries may still have some variation there, but generally it's the same. And some experiments or rather some analyses are standard by the manufacturer. For instance, XRF, XRGs, we don't really have a certain standard to look at, but or the procedure is like an SOP, as a standard method of statement there, right? Reputable, and by complying, flowing a standard way of doing things and a well accepted way of running experiments, conducting the measurements, then we can say that our results obtained are trustworthy, reliable. Okay, you can't be using my own ruler. So my own ruler is my 1 cm. It's different from other people's 1 cm. That's my ruler. I like it. I'm a researcher. I invent on. You can't do that because our ruler is not universal. So when we say 1 cm in our report, it's actually 1.725 cm in the standard metric system. So that is not acceptable. All right. And you can see here that when we run through our research, we are actually doing problem solving, identifying trends and patterns, and coming with an answers, actionable plan, which involves things like optimizing the performance that we have discussed earlier on. So now let's take a look at data collection. The what and the how. We gather information, all right? We can keep turning the handle, as well as to say, and keep churning out the results, right? Anybody can do that. A technician who is very, very experience can do it far better than you and me. Right? But what's the difference between us and them? The difference is that we are taking the data and looking at them far deeper for a specific purpose. Right? So the same set of data coming out from the same experiment, same sample, same method, same approach, so on, being looked by different people, different researchers for different purpose will be analyzed differently, coming out to different findings, different conclusions, different end game. All right. So that is very important. And if you look at the third point here, you see that the data that we collect are being analyzed to do one thing. That is to verify, meaning that whether it is to support or to negate, to refute our research hypothesis, helping us to come to the conclusions. That's why we say the hypothesis, there's no right, no wrong to our research problem or research questions. There's no right and no wrong. Of course, to craft the research questions or how to say the hypothesis, depending on how you want to organize and present your thesis. It is not something we write for the fun of writing. It's not just yes questions like yes or no. I'm going to do this. I'm going to invent this. I'm going to add material A, material B. I'm going to produce this super plastic. This super plastic is going to be stand 2000 centigrade, 1000 centigrade higher than normal plastic. So my hypothesis is that yes, it's going to work. But that's not so simple as that, is it? Right? We can do that with if you like, non-scholarly kind of research, then we can actually say that, yeah, I just put in a statement, research hypothesis, I want it to be 2000 centigrade. At the end of it, if it doesn't, it doesn't, if it does, it does. For a master's or PhD, a registered program, postgrad research program, you have to do it in a very, very scientific and rigorous manner, meaning that if I were to say that I want to create a composite plastic or a novel plastic, which can withstand 2000 centigrade, I'll be very specific on what is the purpose of having 200 centigrade. Is it a component going to be plugged into some kind of furnace feature? Or is it something that is going to go to space or re-entering space? Of that, we are all very excited because Amethyst the second has returned to Earth safely with the astronauts gone furthest from Earth in space travel. So that is exciting, regardless of whatever world conflict we are having. And in terms of the research hypothesis, we must also have a clear idea of how to achieve that, how to answer the question. It can't be just, oh, so I want to create plastic of such capacity. Yeah, how do you create it in the first place? How do you manufacture it? What kind of materials you're going to use? What kind of measurements you're going to run to check the capacity or the performance of that super duper plastic that you say you want to make. So you see the difference between doing a research and doing a postgrad research, a scholarly research. That's the difference there. All right. And don't hang on me now. Just a minute, my slides are hanging. Maybe it doesn't like a Tuesday afternoon too. No one likes afternoon classes anyway. In fact, no one likes any classes. But thank goodness it's online. You are in the comfort of your respective homes or offices. So hopefully it's not so bad. Okay. Right. So the importance of planning a research methodology, running a research, collecting your data, it is about the quality and the accuracy. Okay. We want it to be as error-free as possible. We know nothing is perfect, but as error-free as possible, as simple as typos. These days, there are so many AI assistants, so I think it is very unlikely and it's rather unacceptable these days to still have typos or sentence structure error in our thesis. All right, so use the AI tools effectively and intelligently, and not the other way around, letting AI tools use them. All right. Relevance, validity, and reliability. Got to make sure that the data we collect is relevant to the research objectives. You do not say that you want to collect the weights, the info on the weights of the durians collected this season, and then the answer you have in your chapter 4 reported in the tables are actually the diameter of the durians. You see, simple example, they are not quite aligned with the research objectives, and hence totally goes out of way from your problem statement. I got to make sure that whatever you want to measure is meant to be measured, valid, using the right tools, and the data collected is reliable, complying to certain standards, referring to certain prescribed way of doing things, standard manner, easy put, right? And bias reduction and representativeness, of course, when we run any experiments or take any measurement, there's always bias. No matter how accurate our equipment is, right? We have a steel rule and say, yeah, what I'm using it is starting at 0 at the edge here. So if I were to measure the depth of a cylinder, I can just pop it in. It should be giving me the correct answer right up to the 1 decimal place of centimeter. So the closest I can do is 1.1 cm. Right? So the accuracy is 1 mm. All right. But who is to guarantee that my steel rule has a really flat edge? And who can guarantee that when I pop it into the cylinder to take the measurement, the point that I've chosen, say I only pick one point, is not uneven. That's why it moves on to minimize bias, we take average. So if I have a cylinder, 10, say 5 cm high, I want to measure the height of the cylinder. I wouldn't take just one measurement. I take probably 3 or 4 points and take an average. When I do that, then I realize that really there are errors. And if I have taken just one point, I may have taken the highest or the lowest point, which is not representative of what is really going on with that cylinder. Understand what I'm saying? So one simple example of minimizing the biases. So in the end, you can see that end game, we want to enhance our findings to some kind of generalization. That's why you and I like to do regression chart. We have a lot of points on our chart and we put in a regression line. Ideally, it's a linear line. If it's a linear plot, ideally it goes through the origin, 0, 0. If it doesn't, there's a y-axis intercept, then I know that there's some kind of hangover, meaning that there's some kind of value even when my x-axis parameter is 0. So I've got to be cautious. There's sometimes it is not logical to have a 0 value on our x-axis parameter and have a y-axis value there. Right? So depending on the situation, not necessarily, it doesn't matter whether you are using the softwares or Excel, Origin, or any other software. You may even use more advanced stuff like MATLAB to draw your graphs. They are just tools in the end. If you like to think of them like advanced calculators, right? All the softwares and all. But if we don't know what we are keying in, all right? We want to calculate, we want to, okay, simple example, we want to know what's the answer of 1 plus 1. Of course, everybody can just do it by hand, and because it's 1 plus 1 is 2. Say 1 plus 1, I don't know. So I will press on my calculator buttons 1 plus 1. But if I don't know, that is the way to press the button. 1, I don't know how to use the calculator. 2, I don't know the concept of 1 plus 1. Is it 1 times 1? Is it, what's the difference between 1 plus 1 and 2 minus 1? I don't know. The answer is the same. I don't know. So I have no understanding of the concept. Then it ends up having the calculator as a tool is not helpful to me. It may even end up giving me more faulty answer than if I had done it manually. So you see, my dear student, having all the tools, whether it's software or hardware, it's a experimental setup or it's a measuring tool, or a algorithm, anything that you use to gather data, it is only as good and as accurate as you are. I repeat, as you are, meaning that as good as the researcher's understanding and hence commanding the equipment, commanding the software, commanding the algorithm, using the tool to take the measurement, to collect the data. All right. And coming to post-analysis, once you're done analysis, then we're talking about informing you to make the decision about in your case, about the hypothesis. And in your case as well, as a research student, you want to address objectives, close the loop with the problem statement, and to support validity and reliability then. So if we trickle it down to look at data can be further segregated into primary data and secondary data. So quickly, primary data means original data, raw data. I collect by myself. It could be I measure them themselves, I run the surveys myself, I conduct the interviews, so on and so forth. Or there can also be second data. Most straightforward example, data that I borrow from the literature. We all do that, don't we? especially in science and S&T research, we always need to compare our results with other people. If the trend is generally going up, ours is going down, or what is happening now. All right. So, and its logic tells us that it has to go up. I increase the heat, the temperature goes up, but mine is going up and it comes down. So what is happening there? Is it common? Has it been reported before? So when I start looking at other people's data and pop them into my graph, but of course I start there, this is by who? The different symbols and legends there. So those are secondary data. Okay. But we are doing all the time. Mhm. And when we are collecting these data, the primary data, the raw data, our own data. And this is where we can say, is it a quantitative data or a qualitative data? So if we are talking about the quantitative one, so you don't have to memorize all these. And remember, at the end of the day, you are using this research methodology class as a, if you like, giving you an idea of how to plan your work, right, from beginning until the end. And it's not about taking a research methodology course as a course, meaning that you're going to sit for an exam on research methodology. No. All right. That's why this subject has got no tests, no exams. You have just a task, sequential task assignment that builds up your research proposal at the end. That is the whole topic actually. All right. So for quantitative method, generally we can say that time series, the smoothing technique, barometric method. I'm not going to go delve into these because as I said, we are not this is not meta research methodology class, right? Um, probably closer to us, more common to us would be the time series analysis. We do that over time. The temperature change within the past 3 months. We have had very hot season, hot weather these past weeks. But we also have torrential rain. So of course, when it rains heavily and for a prolonged period, then the temperature will go down. So if you were to chart the temperature change daily, from the January the 1st right up to today, which is 14th of April, you'll probably see a lot of up downs going on there. And from there, if you tally with another chart, which is a rainfall chart, you could actually see that when there are higher rainfalls, then the temperature will actually be doing that. So simple example, that time series based. All right. How you collect them and all some ideas here. And look at this yourself if you like. And as for the secondary data collection, where do you get them? In our case, most of the time we'll be looking at the literature, or you can looking at database archives for civil engineering works. It involves the site. Then maybe we may need to pay a visit to the local public works department or the local council to look at the past structure plan of the place and things like that to get an idea of land use, of town planning, for instance, to know about how the traffic, if you're into highway engineering and traffic management, you want to know about the next 5 years traffic management plan of a place so that your proposed solutions will be applicable, right? And incorporated into that design and not something that is, again, just chit-chatting, not resolving any problem at all because it's just everything is on paper. If no matter how good the solution is in the end, it is not going to be applicable out there to a certain problem that you mentioned in your problem statement. All right. And it's also highlighted here that secondary data usually is less time consuming or even free, all we know. All right. Or while you are still at the university, well, by all means, access all the database that the university subscribe to, Science Direct, Scopus and all, even the British standards. If you're out there, eventually when you graduate and you have no longer the access to it, you got to buy them and they cost thousands of ringgit. All right. So while you're here, might as well you download them. The British standard, I know you can download from our PTTA, the library website. And ASTM, the last time I checked, is still downloadable. So yeah, download them. You never don't have to download everything. Download those pertaining to your work out there in the industry and so on. Let's take a look at the model testing and validation. So whatever research model that we have in terms of research methodology, we got to make sure that it got to be tested to check on what the validity and the reliability, as we mentioned earlier on, right? And usually we look at empirical the data to determine the relationship, the correlations, and whether the model is going to be a linear one, a hyperbolic one, or is it a power law one, or um, even a polynomial one. So these are some of the common names I mentioned here that you have probably familiar with in Excel. Those are the regression, the fitting analysis that Excel can run for you. If you use more advanced scientific software like Origin, then you probably can find more complex, more complex, more in-depth analysis that can be done. Then you want to have double y-axis on the variable scales. So this can be done in Origin. Excel may have limits to that. All right. But all in all, my personal experience is that Excel, even though it is designed for finance analysis, really, financial analysis, nonetheless, it is for um, conventional scientific data analysis and presentation in terms of charts. It is still all right. Of course, I have never tried to superimpose statistical analysis onto Excel, so it's not fair for me to make comments on that. But if you have a lot of data and it involves statistical analysis, then obviously we are going to go for SSS and NOVA and so on and so forth. And just a quick advice, if you know that your work is leading towards that path, meaning that you need to do statistical analysis and you don't have much background in that, go join the classes. All right. In the university, I know that the Faculty of Technology Management and Business at FPTP, they do run classes like that in their standard practice. So you could actually find out the timetable and ask for permission to join the class. The lecturers will not say no because this is all knowledge knowledge dissemination there. Okay. Mm-mm. If you want to register for the course, so that is on the transfer and all that, you have to inquire from the Center for Graduate Studies, okay, and see if that can be done. So it's like you want your transfer to be more value added, but it's up to you. Okay. Right. In terms of model validation, then we are trying to evaluate the logical arguments based on scientific evidence. So essentially now, we want to see whether the model that we have derived from the data analysis uh, applicable is applicable to other data of similar nature, meaning that is this model, that this chart, this regression plot that I come up with, this relationship between Y and X is applicable to other people. Say in my field, okay, I have this model for soft soils that I found in the Johor area, all right? So can this model, I relate, say Y-axis is strength, X-axis is the liquid limit, for example, can this chart, the relationship that I got here, say a linear correlation, can it be applicable to soil from Malacca, Selangor, Sabah, Sarawak? Is it applicable? And if they are not applicable, is it because of the location, the geographical differences, or is it because of the soil property? So that it goes on as validation of my model. But you got to be very, very specific really when you try to come up with a model that what are the parameters, what are the constraints and scope rather that you have used to derive that particular model. All right. And you may even have external validation. This is especially true for those who are into qualitative studies there. And these days, even people who do a lot of it used to be called ANN, right? The neural network thing. But these days they are called machine learning and data mining and stuff like that. So again, you have to run sensitivity tests and so on with your algorithm to make sure that the model that you come up with at the end is something that is valid for a certain type of sample or certain category of sample. It is the dream of every scientist and researcher to come up with a universal model that fits everything. All right, like what Einstein had proposed to do. But apparently, it's not so simple. All right, so many variables in there, whether it's from the material itself, or the test method itself, from the surrounding environment and all. The too many variables in play to come up with a single, unified, universal model to explain everything all at once. So it's I think to date it's still rather impossible. But there always be models and sub-models to explain more specifically pertaining to a certain phenomenon, a certain a specific material, or in different situations, with different circumstances. All right? Right. And I found this and I thought this is not really the best example, but I thought it could probably convey the message of why we need to do validation testing. So this is an example from the business sense, business scenario. All right. So it says here, for instance, you look at the third point here, it ensures that it confirms your stakeholders' requirements and expectations have been met. So if this has been coming out with the innovative product, for instance, say earphones, all right? Earphones now have gone to various shapes. Some are conical, poked into the ear, so they have maximum noise reduction, not sure. Some are like P-shaped like mine, supposedly ergonomic and comfortable for long time installation to the ear, so on and so forth. Or no matter how good our innovation is, how good our invention is, at the end of the day, if nobody wants to use it, then we fail. We fail in terms of actionable finding, right? So it has got to resolve certain problems. So in the first place, if I were to innovate or my research is in trying to improve, for instance, a mouse design, right? The mouse, how ergonomic of it, or the lightweightness of it, or the energy saving of it, or the precision of it, whatever. The scope will determine that, right? So my problem is what? My problem statement is that people have been complaining that the current mouse, even the most advanced one, is causing some um, metacarpal tunnel syndrome to those who are using it long term. So this is a very common thing for those who do repetitive actions to their hands, right? So only the nerves along the metacarpal is on the opposite side of the upper part of the hand is the palm, so the opposite side of the palm can get painful there. All right. So similar like people who play a lot of games or people who do a lot of work with their mouse, programmers, designers, and so on and so forth. So you want to resolve the problem. So that is a problem statement. You see that? And once the thing is done, say this is my prototype mouse, super duper mouse. How do I know it's all right? I got to have somebody check it, right? So who do I get them to check? Yes, those who are the end users, those who are going to use it, using them for long hours. So you see, this is where you see putting out there, those that out there, the invention out there, and to see whether I can further improve it or whether my hypothetical validation is not good enough. Hypothetically is good, super good, right? Tick all the checklists, but from the user point of view, there's still some room for improvement, for instance. Okay. Now, and we look at statistical tests and correlation studies. I'm not going to take you through statistical analysis. I said not everybody is going to do that. And for those who are going for it, make sure that you have mastered the tools, all right? So that it wouldn't, when you come to it and you struggle to go to make time, to find time to go for the courses. Right now at the beginning, when the data has not started coming in too much yet, you still got some time, some spare time. Go learn, all right? Go acquire the skills of using those softwares first. So again, we look at the quantity data, it's like talking about quantity, amount, the range, and when we talk about quantity and number, the twin is always the units, right? And of course, you have arithmetic operations coming in. Look, it's arithmetic. It's not even mathematics. We are not even talking about what do you call that? Calculus. All right, dy dx. We are not talking the squiggle integration. No, we're not talking about that. We just talk about integration. Oh, sorry, we're just talking about arithmetic here. So it's plus, minus, multiply, divide, like Ed Sheeran's song album. Yeah. It's just arithmetic, right? And the difference between quantitative and qualitative data is that simple way of looking at it, numbers versus text or picture. Yeah. Closed data versus open data. Or if I measure the length of certain samples, yeah, text number, they're all the length. But they are closed data, just length. But if I were to do some qualitative data, just to interview, the very same question can draw a wide range, a very big range of answers coming in. So that's why people who do qualitative research really, really got to be very cautious of their recording, whether they record it as a video recording or whether it's a voice recording, because they need to transfer later on, right? And turn those information into workable format. And hence it's of different nature compared to those who do quantitative then, right? Statistical versus various analytical approach and generalization versus specific. Another diagram here, you can see if you're talking about quantitative, it is that pretty much very measurable. I can measure with a certain tool, like temperature, like the length, and the weight. And you can use a ruler, a beaker, a measuring cylinder, thermometers, all the devices, the measuring devices I have, like LVDTs for displacement, strain gauges to measure the strain converted to calibrated towards strength. Okay, but qualitative is more like something that we observe, right? We interview, we listen, okay? We go to a classroom, we want to know kids' behavior, then we observe and we make records on that, okay? That's the data coming in, right? In a simplified manner, you can see, the quantified ones are, scores, weight, shoe size, the quality of durian. That is qualitative. The smell, the thorn size, the thorn sharpness, the durian skin color, the aroma. How do you quantify aroma? Right? Some will like it acidic, some prefer it to be more woody, some may want it to be more pungent. So it's very, very subjective. All right. Even colors. Colors are considered quality unless you talk about the breakdown of colors or the basic colors are what the blue. Am I talking nonsense? Yeah, talking nonsense. Green, yellow, and one more, forgotten. So the basic colors mixed up at different ratios, you come up with all the other colors like purple. All right. So we need to know the baseline, and then you can move on to other things. So people who study colors, the chromatic analysis, so it matters. All right. The colors, original colors quality, they can be turned into something that is quantitative and something that we will want to look a little bit more into later on. So now take a look at this interesting table here. Actually, it's a chart, objective versus subjective. So on my column here, I see is objective, subjective. On the in the row here is objective and subjective. In the column, we have qualitative and quantitative. So this is just talking about the description of a computer I own. All right, a computer. You see, it is very old-fashioned, 2 gigahertz. I have not changed this into tablets or those phone capacity now. Just go to back to the basic stuff. So if I was saying that I'm being objective now, right? I'm being objective, and I'm being quantitative as well. So objective and quantitative, meaning that something measurable, something quantifiable. So I'll probably say something like the chip speed is 2 gigahertz. But for the same answer, I'm being objective, not biased, specific to a topic, but I'm being qualitative. I'll probably just answer, yes, I have a computer. You see the difference? I'm still talking about the same thing, but the way I look at my data is different now. Similarly, if I go for being subjective and yet quantitative, I say what? On a scale of 1 to 10, my computer scores 7 in terms of what? Speed, in terms of user friendliness, in terms of what? In terms of processing power. So now it is still quantitative because I put scale to it 1 to 10, but there's subjectivity in it. Because now when I say my computer scores a certain my computer's performance, when computer performs depends on many things from the screen pixel, screen quality, right down to the processor, everything is an contributing factor. Similarly, if I say now I'm being subjective and I look at my data qualitatively, answer could be I think computers are too expensive. I think sensory, I have feelings. I put in my feelings into it. I put in the affective part of things into my judgment. See that? So if we look at this, being subjective, looking at things qualitatively, the answer could be vague. Could be vague now. So in terms of research, it may not help me to close the loop and reach some meaningful conclusion. All right. While we can mix and match, depends on the situation. not all situations is not suitable for all situations there, right? Somehow if you draw on the slide for too long, it likes to hang. It's bizarre, just a minute. Any questions so far? I hope you don't find it too boring. It's just, I said, it's not a test or exam. It's not a kuliah. It's not a lecture. It's more sharing. And I hope you just hear this droning going on and it come up to something that gets hooked in your head and is useful to you along the way when you do your research planning. Just a moment. I can see that it has disappeared from the screen, but on my screen it's frozen. Goodness. Okay. There we go again. Right. Okay. And then we look at data. If you say they are discrete or they are continuous. I put this simple example here, which is on the temperature monitoring. All right. So if you look at the chart given here, they just have the days, okay, for the week, Monday to Sunday, and on the x-axis is the temperature. All right. And it is reported every day. So presumably, we can only presume that if you report daily, so it's the average for the day, all right, and not taken at a particular time of day. Or if it is to be taken at a particular time of day, then it should be taken at the same time of every day, all right. So if you look at this, you see that there is some discrete data, and then there is some continuous data as well. If I were to join the plots, all these bar charts, if I were to put a line through them, it becomes continuous over time. But if I put it in bar chart, it looks pretty much discrete data there, isn't it? That's why the same set of data, the way you analyze and present it will come out very differently in terms of the reporting, in terms of the discourse, right? And remember, we talked about this, something qualitative can be converted into quantitative as well. For example, I have a data set of students' performance. I say you are ranked poor, fair, or excellent. And then I say that I apply a number to it. And say if you're poor, you score 1, you're fair, average, you score 3, if you're excellent, you score 5. So this is actually turning something that is pretty qualitative into something quantitative. Because I could say, well, how do you do mathematics? I know how is your mathematics perform? Well, I do fairly well. To you is fairly well. Maybe to the teacher this is poor. Right? Not similarly, how is your science? How is science coming along? Well, I do pretty good. Excellent. But when the marks are being shown in class, they are actually below the average, for instance. Right? So that's why we put a number scale to it. Poor, score 1, fair, score 3, excellent, score 5. I may even further categorize. When you want to score excellent, you must be between 75 to 100. Fair is between 50 to 65, for instance. Anything below that is considered poor. All right. So that's how you turn something that is qualitative originally by saying it's poor or fair, excellent into something that you can measure and put a number to it. And second example, how many people are there in the classroom, or how many people have been using this particular facility or public toilet or something like that. So I count per the gender. I may even further divide into the age group. I may even further public toilet, for instance, you say further segregate into what are they doing in this place? A public place is a park, for instance. Do they come here for picnic? Do they come here for a run? Do they come here for dating or whatsoever? You get what I mean? So something qualitative again, originally the data, it could be converted into something that is quantitative, depending on how you analyze it. And this is another example here. If we look on the y-axis, is about analysis, qualitative, and the data coming in is qualitative or quantitative. So let's take a look. This is very interesting. Look at number 1 here. If I'm talking about my data being qualitative, but I run my analysis, and I run my analysis qualitatively as well. So this could be looking at the goals, missions, vision of a company or organization. Say I'm going to examine or investigate the performance of a company. So I look at the mission, vision, and the goal. So looking at that in a qualitative manner, so I'll be understanding them. I'll probably be going through the words being used and trying to define what is meant by them and what is the link between the vision, trickle down to the mission, and then trickle down to the goals. You see that? So it's wordy. It's all words there. If I move on to having the same data now, okay, the same qualitative data statements of mission, vision, goals, and I analyze it quantitatively. So now I probably be looking at how do I measure? How do people, how much do people understand the mission of the company? How much of our goals have been achieved? Say, in terms of different department, how many percentage have they achieved their three goals? Say, for each goal, goal A, goal B, goal C, each department, what is their performance? What is the achievement for each one? So I start to be able to rank them and rate them. So to do that, I develop some kind of survey tools. I may run interviews, some kind of measurement being put into the data. Same thing for the other two columns there, two squares there. All right, you see that? So they are interchangeable depending on what you do with them, how you process the data, how you run the analysis for the data. Okay, and another telltale, another way that we can identify whether the data analysis method being used is quantitative or qualitative is the terms, right? The words that they use. So as we have mentioned earlier on, quantitative is numbers, numbers, units, numbers, units, right? For qualitative is a lot of adjectives and verbs even. Okay, so moving in to analysis. So talk about analytical approaches, of course, the qualitative, quantitative, we only focus on the quantitative here. Should you need advice and help in quantitative, I strongly recommend you to look up the lecturers in FPTP and FPTV. They will both have experts there. Will be able to better advise you in terms of running qualitative research. I'm not saying that you can't find them in the engineering faculty, engineering technology faculty, or the science faculty. I'm just saying that in the uh, faculty of management and education, the odds of you finding someone who knows this and who does this regularly will be a lot higher. All right. So if we take a look here, talk about quantitative research or quantitative analysis, and the work moving or the mechanism is very much deductive. Deductive comes from the word or rather comes from the root of deduce. So to deduce is making informed prediction, if you like a detective work. Okay. So in this sense, can see that in comparison to the qualitative analysis, uh, the qualitative people are doing the inductive way. They induce a theory out of it. See that? You deduce, you work based on theory, you work towards it. Based on that theory, you work on your analysis. Inductive means based on my data, I come up with a theory. So they are very, very different approaches in a simplified manner. You can understand that way. So as I said, our focus is on quantity, so let's take a look. To run a quantitative data analysis, you can say that, yeah, roughly 3 stages and 6 steps, roughly. So remember I told you, running a quantitative data analysis is a deductive work, deductive process. So the steps could be like this. For the first stage, we are trying to frame the problem, all right? So I tell you this, my problem is floods. Okay, floods. You can't just take a problem flood and you start running a research. No, you got to identify what exactly is the problem. Is it flooding, or is it blocked drains, or is it leaking pipes? What what is causing this flood? You get what I mean? Then you scope your study. So that is about framing the problem. So you first identify the problem and you start to review the information you have from past findings, existing records, site visits, things that are already in existence, not that you have to go and take measurements. All right, things are already there in the past, in existence. You gather them, almost like that study, if you like. Once that is done, you try to come up with some hypotheses, the modeling, right? And then I go gather my data collection. It could be lab experiments. It could be going to the site to take measurements. It could be based on secondary data. You run the analysis, okay? And then I churn the numbers, all right? In my analysis step. Done, I project those answers into findings, which are then being discussed to draw conclusions. What kind of conclusion I'm talking about? Conclusions that answer my problem statement from the beginning. So you see, there's this thread that trades through the whole process. Anywhere where the thread breaks and there is a disconnection. And that disconnectivity is going to cause us problem when we try to conclude our thesis in chapter 5. You see that my conclusion is based on my findings, well and good, but my conclusion doesn't seem to answer my problem statement. That means somewhere along the line, we have a missing link or a kink. It's like folded connection or broken connection, if you like. Right? A kink is a fold in a pipe or in a thread. So the kink like this needs to be addressed. And again, another example, when you run quantitative data analysis, it could be that you start by understanding what the requirements, what the scope, what exactly is the problem that I'm trying to resolve here. All right. And then I have the data. I have to pre-step what kind of analysis I'm going to run. So if it's an experimental world, then it will be the charts coming out, the data coming out, because data coming from experiments from standard methods are usually being plotted in a certain way. So I must already have some idea of what kind of analysis I'm going to see. And then I design my research methodology. Right. I will design it as samples from where, how many samples, sources, availability, do I need to repeat them, restock them? What are the measurement methods? Is it in the lab? Is it in that lab? Is it on site? Do I need to do modeling, numerical modeling? And then I go on to run the experiments and collect the data. So once that is done, you can roll out the plan and have the findings presented. You see? This is an interesting section of our sharing. It is about starting in one place, ending in a totally different place. What did we say? Our research work got to be coming full circle. I start with a problem. I go the journey to find the answer. In the end, I do come back to the same point to close the loop. The circle must be completed. If I go a straight line or irregular line, it doesn't come back to answer the question. You find that you end up having a chapter 5 that's very, very difficult to close. No ending, no closure. So you cannot leave the thesis like this. Understand? So having said that, meaning that right from the beginning, when you plan your research, the research design leading to your research methodology plan has got to be done in at least 70% and above correct. In that even as time goes on, second semester, third semester, you tweak your project, it is still 70% as as is the original plan, and not 100% changing all the time. Because if you keep doing that, like what we mentioned right from the beginning, you will always be running on the same spot. 2 steps forward, 3 steps back, 3 steps forward, 2 steps back. So eventually it's running on the spot, not going anywhere. Eventually you get frustrated as the student, and that is when will loom in your head the idea of giving up. So we don't want that to happen. A research study is supposed to be a very, very structured, organized, well-planned journey where you have clear points where you will check yourself. We call them the milestones, right? We'll check ourselves on the achievement of progress. Don't say achievement, progress of our work. And from there, cumulatively, they'll lead us to the end of the journey. All right? So you can't sprint. You have 5 checkpoints, and each checkpoint is 1 semester. You cannot possibly expect that at the end of semester 1, you have to reach the final checkpoint, the finishing line. That is impossible, right? It's a step-by-step thing. And It's not a horizontal step-by-step thing. It's actually a step-by-step upward thing. It's like a mountain climbing experience, a learning curve, all right? A learning curve is always going upwards. Of course, the initial bit will be very steep, a steep learning curve, because we don't know much yet. As we learn, as we progress, as the milestones are being hit, you find that, oh, the beginning is steep, and then it gets less and less onerous. The slope becomes more and more gentle, actually. All right. So come back to these slides here. We may begin qualitatively and we may end quantitatively. So this is a bullseye where you do archery. So imagine this is a bullseye. So if I run a qualitative research without quantitative elements in it, I may be having all my arrows shot at the same place. Very close to the bullseye maybe, but never quite hitting the sweet spot. Right? Like playing tennis, right? And the racket, maybe these days it's more popular to play uh, pickleball. So there's always a sweet spot on your paddle or on your racket there, like badminton as well. So don't quite hitting that. If you are running a quantitative research without the qualitative element, maybe we are having this problem. Our data points seems to be correct because we always get about same range, right? Same range, same place. But actually they are not the bullseye. See the difference there? Okay. So what we are seeing here is if we are using only qualitative approach, all right, we may be asking the right questions, but maybe we don't get enough data, enough range to accurately answer the question. Hence, we may be getting answers that is biased. So we keep hitting the same point, the same point again, again, and we thought that we hit the bullseye. But actually we don't. Okay? And it may be just a fluke that we are near the bullseye. This point that is being repeatedly hit, maybe here, maybe elsewhere, maybe even outside the lines. Okay? Asking the right questions, not quite getting enough data or not quite getting the correct data. The other way around, quantitative research without qualitative analysis. Accurately answering the question, giving the right answers, but the question is wrong in the first place. There's a lot of flooding going on. So what is the main cause of the flooding? I asked the people staying around that, oh, this is because of climate change. Yeah, they say climate change. I asked 10 people, 10 people said, okay, climate change. So I scope my research to climate change causing recurring or increasing severity of flooding issues in Johor based on interview of 100 people, local community, totally reliable data, totally honest answers. But the problem is, and their answers, of course, generally people say climate change, right? That is not wrong. True. That is true. Is that the right question to ask? Or is that the right people to be sourcing the question in the first place? Not wrong to ask the local folks. Have I asked the people who gather data, who monitor information? For instance, the local council, the public works department. Public works department take care of the roads. The roads are getting more and more potholes. Maintenance are recurring more frequently. Due to what? Due to more damage. Why more damage? Because of more water um, uh, being retained over the pavement. Why is water retaining on the pavement? Because of flood. Oh, that is something. I talked to the drainage department. They take care of drainage and tell, oh, we have been widening our drainage for the past years, but they are still not high capacity enough to take the runoff. So something is not right. Our design for the runoff is not catering for the capacity is not catering for the total runoff. So yeah, climate change. You see now you see the bigger picture. So you must be asking the correct question to get the correct answer. But the first scenario, I asked the question, but I asked the question to the wrong people. So in other words, not quite the right question, right? So the answers are correct. It's climate change, but it's only one-sided. Hence, I am not quite addressing the problem in a holistic manner, or not answering the question, not solving the problem in a spot-on accurate manner. We may be confident we are hitting a certain area. We may think it is the bullseye, but actually it's not. Just because we keep getting the answer in that range doesn't mean that we are hitting the bullseye, like in this case. But we don't know because we are so far away from the ball, the what do you call that? The bullseye board. So we don't see. We thought that we are getting it the right place. We don't see. We are so near to it that we don't see. Right? So this is the danger of it if we run quantitative research without much qualitative analysis. So the long and short of it is that, look at the second one first. If we do qualification without quantification, is my slide disappearing on you? It's still showing on mine. Just a minute. Okay, it's back on. Okay, yeah. So let's look at the bottom one first. We do qualification without quantification, maybe inaccurate, asking the right question, but we don't quantify it. We can't quantify it, right? Quantification without qualification, you have the shots coming through the same place all the time, range. And then we thought that we are getting the right place, but actually we are not. So we may be irrelevant, wrong questions, so a lot of data, but pointless, useless data. Just a minute. Why is it that I've stopped sharing? Hang on. Just a moment, yeah. My laptop is having bad connection. It says I lost connection. It is trying to reconnect. Can you still hear me?
Yes, Prof.
Okay. So meaning that the mobile phone is all right. It's the laptop that's doing out just a minute here because I see the Wi-Fi is all right. Strength is good. But somehow I got kicked out in my laptop here. Just a minute. I'm joining again. All right. I'm in. Oh, that's nice again. Okay. See the slide shortly. I think it's a lagging here. A moment. The laptop says that it's sharing. Very good. But then again, you can have this slide is in author, yeah, they are already uploaded there. So we were here. Okay. Now we go on to data presentation, which is one part of the research design, research methodology presentation. Because to make sure that when we present our data, after doing all the hard work of collecting data, running analysis, whether it's quantitatively or qualitatively, that they are contextually grounded. Okay, in the right context. Same data, different people look at it, they have different purpose, different discussion, different context. Theoretically correct. So regardless whether you have a hypothesis that is going to break down against the current hypothesis, still it has got to be theoretically correct. For instance, a certain material, it expands when the heat, the temperature goes down, and it contracts when the temperature goes up, which is counter logic. If that's the case, then that's the case. So that's the starting premise of your study. It differs. It's different from project to project, material to material. So theoretically, fundamentally, it must be correct. And a contribution to certain sector, to certain profession, the findings are actionable. That was a positively actionable plan that can be used to make things run better out there. Otherwise, there wouldn't have been a problem statement in the first place. All right. And in reporting our data, I got to make sure that there's enough information given. Okay. Sometimes we forget our legend in the graph. Sometimes our legend is incomplete. Okay. Sometimes we forget to mention our sample size. So little things that make sure that you don't get into trouble like this. Okay, the next few slides here are giving examples of the common mistake that we make when we present our data, whether it is in a table form or in graphs. Okay, take a look at these tables here. Is there any problem with it? Do you like it? If it's your own data, would you do it? Of course, these it doesn't matter what the information that the data is about, but if you like, it is collecting the information about the agents. These are names of people, Gary, Charles, Brad, and all. And these are the sales figures for a certain region. So just the presentation of the data in this table. Is there anything that you want to say about it? Do you like it or you don't like it? If you don't like it, what is it that you see that you don't like? This is the time you can turn on your mic and participate in the discussion. Right? Anyone? Oh, you're mature students. I need not call names. Just turn on your mic and say something. Anything? Yeah, just turn on your mic and say.
Prof,
Yep.
Inconsistent
Which part is inconsistent?
in term of the decimal, the perpuluhan,
Okay, decimal place. Good.
and then the how it goes, the position should be the data must be all in the right side, so we can
So they are
see
not aligned.
it's not
Okay.
line.
Good.
That's all. That's the main.
Thank you, Harry.
That's the main. The rest, okay lah.
Anybody else you want to add? Apart from the misalignment at the decimal place, the data originally got no decimal place. Suddenly, when it comes to average, there's decimal place, not consistent. That's Helmi's observation. Anybody else? Is that all? So you probably see that some bold, some not bold, some itemized, some not itemized. So basically, and too long a word and the S has dropped to the second line. Basically, it's very, very untidy. So the same data, you can actually make it a lot neater. All right, keep it simple and say elegant, minimalist. Same thing here. A lot more pleasant, a lot more easy to understand, right? A quick glance, already you can see that, oh, okay, got it. See? No need to have the decimal place. It's not going to make a lot of difference there. A line, only bold for the final answer. That is the average. The rest of it need not be bold. There's no need to wins and fancy we italize or bold any of the text, any of the numbers. Okay, keep it simple. Second example. Okay. Is there any issue with it, or you're happy with this table? Starting from the title. Anything? Anyone? No?
Title's too long, descriptive.
Yes, title. Well, if I finish reading the second line, I forgotten what is in the first line. 39 words. Actually, that need not be so long, right? Just keep it short. People have no time to read a 4-line title for your table. And just a quick reminder, when we have tables, the title for the table is on top of the table. When we have a figure, the caption for the figure is below the figure. Well, it's good to download a copy of the thesis writing guide. I think the latest one has been released last year, was it? Look at it and make sure that you follow the template. And I think CGS has a template issue. Take it, don't take your seniors, and then if your senior is wrong, you continuously, making the same mistake. Then you see it's rather particular about the format, spacing, the margins, and also make sure that you get them correct. Okay. Right. Third example. If you compare the top and bottom one, the bottom one has been improved, obviously. The similar problem, right? The decimal place inconsistent, unnecessary vitalization, and the first table even, if this is a production report, then we will expect to see some kind of average because it's showing a time series, right? Over the past 4 years, 1990 to 1994. So in the improved version, they put in the average as well. Okay, and then quite quickly see the performance of these respective source of logging. Okay, now we look at the graphs. Yeah, in science and technology, so drawing graphs is going to be like bread and butter to us. When you come to churn out your data. So anything wrong with this graph? Don't bother about the data. Just if you see a graph like this, you take issue with it or you're happy with it. Anything there? No issue? Anyone wants to cross?
It doesn't start at the origin, the 0.
Good. When there's no necessity to do that, right? So this is common, all right? This is commonly done by Excel. So be careful when you use Excel plot your graph. As I said, it was created to do financial analysis. So it follows the logic of money. And deficit is negative. That's why it tells out negatives happily. For in our case, in engineering terms, for instance, you measure the length or the weight of things, the mass, temperature, you have negative, but the weight, mass, length, negative doesn't make sense. So be careful to double check the graphs that Excel produce for you. And of course, more subtly that we don't quite see, and we commonly do this in our own the graph condition is we overdo it. For instance, 2 sets of data, right eye and left eye. If I were to change the symbol, one is a blank circle, one is a filled circle, good enough and need not change the line type, right? But if I want to use the line type to differentiate, all right, the 2 different data set, then there's no need to put in the different symbols because they are pretty easily readable. You get what I mean? You can just put a ruler there, draw a line that can read the pupil dilation, also pupil diameter on the y-axis pretty easily. So it depends on what you want to show, but there's no need, like in the original plot, they use 2 ways to differentiate the 2 data sets. You change the symbol and you change the line type. There's no necessity for that. All right. Moreover, these days, DCs are all in electronic formats. You can have colors to differentiate the different data sets, not like previously when we print our thesis to save cost, we print in black and white. So I've got to make sure that the symbols will differentiate the different data sets there. Nonetheless, my dear students, consider this as well. While you are going to submit your thesis, most likely only in electronic format without having to submit the hard copy, people looking at your work eventually, which you like people to refer to your work and cite your work, will be printing your work maybe, right? Printing out your chapter 4 to compare your results, Unlikely they will print in color because it's expensive, right? And to save nature. So if they print in black and white, would they be able to differentiate the points, the symbols in your legend? So that is something to think about. So my little advice is that if the data set is not too many, use symbols to differentiate the different data sets. Start with that square. In Excel, you have square, circle, asterisk, triangle, and you have a diamond shape, right? So that already got 4. You put filled and unfilled, you have 8. And then you have the asterisk, you have the cross, you have the plus symbol. Again, 3 blank and 3 filled. So already you have 6 plus 8, you already have 14 there. So I think 14 is already quite substantial to be presented in a single graph. So if you could do that, then it will be, people say, beneficial to the people who are going to refer to your work and print out your work later on in black and white. Okay. Now, quickly, we look at the analysis of quantitative data more in depth. Essentially, we say that 3 steps: we validate, we edit, and we code them. So the first step is to validate the data. So the purpose of validation is to find out, as far as possible, to the best of our ability, whether the data collection has been done against or with reference to a preset standard and without any bias. The whole point again by a standard is that standard procedure, standard reference is to make sure that anybody else doing it, whether it's here, there, or everywhere else on earth referring to the same standard, you get the same answer. That's the whole point of it, right? Otherwise, you say the same task, but different ways of doing it, they come out differently. So that is what we don't want. And they said there are 4 ways of doing it: fraud, screening, procedure, completeness. So very quickly, this is interesting. Fraud means quickly identify, is there any strange data outlier? Okay, some strange ones. For instance, someone who did not actually answer my interview or answer my survey, but the answer came in. For instance, did I manipulate that? Did that answer come in from the same person who answered my survey forms twice? For instance, I screen. I got to make sure that my sample, this is a case of interview, right? My screening, the respondents or the source of information, source of data coming in is in compliance to my research criteria. If I say that I want to examine only the fine-grained soils, okay, the permeability of the fine-grained soils, then the samples that I take in to examine must be fine-grained soils. I can't be having samples clay, which is fine-grained, silty clay, fine-grained, and suddenly I have a sand. The sand sample is obviously not in the category. So if we start off by having a sample that is not even complying to my own research criteria, which is fine-grained soil, then how can I expect the data to be valid? All right. Next, the procedure. Check that my procedure is being strictly followed when I'm doing it. When it says that when you put the soil sample in the oven to dry, you got to open the lid. But I kept my lid on. So that is not going to standard procedure. Of some, I put the lid on, some I put the lid out, some I put half closed. You cannot do that. Okay. You must follow the procedure exactly the same for all your samples, all batches of sample. So this is just a reminder for all students who are running experiments later in the lab. Simple thing as taking the water content, moisture content of a sample. Just pop it in the oven, take it out and weigh. Simple thing like this, whether you put the lid on or don't put the lid on, it matters, right? It may not change the answer significantly, but it goes on to show our rigor, our discipline in running our research and experimental work, right? And last but not least, we look at the completeness of our data collection. Have we unturned every stone? If we say we are going to interview 10 people, have we really interviewed 10 or only interview 8 and report them as 10? Okay. Next, we look at editing. So the editing is not manipulating the data. Editing is checking my data, okay, and identifying the errors, outliers, anomalies, and try to see what are the ways I can, what are the ways that can help me minimize the error. Okay, if worst come to worst, I have evidence to show that that particular data point is an error. I have the option of deleting it from my analysis or redo the test, retake the measurement. But a lot of times, once we have passed that stage, the chance is passed For instance, I measure my data is about traffic management. Yeah, I'm to take, I take this data of traffic passing this stretch of this entrance from 7 to 8 in the morning for January. Now it's April. If I run my analysis, I find one funny point. I can't go back and do it anymore, can I? January, first week or the month of January 2026 is passed. I can't go back and do it anymore. So for instance, so that data has to be removed, okay? But if it's something that I measure in the lab and the sample is still there, the sample has been kept unchanged, so I can go back and measure again. Or I run a simulation and I can run it again, so I can do it to just double check if that is a fluke or really an error or genuine. You see, you get what I mean? So that's why, my dear students, your samples, when it's done, don't be too hasty to throw it away. All right, keep it, label it nicely, just in case you need to revisit it. All right. So now let's take a look. How to deal with outliers, or data that is way out for other people. So if you take a look at this set of data presented here, it's about the total amount of money in the cashier, if you like. All right, it's a shop. Every day at the end of the day, they will calculate how much of money is in the cashier. So if you take a quick look, day 1 to day 12, almost 2 weeks there. Blah blah blah. Day 4, suddenly there is a big number there, correct? Which is unlikely, right? Unlikely. So an outlier, you got to make sure, double check, go back and review that particular data. And you can also quickly and easily detect an outlier by plotting it out. So for instance, in this case, everybody is in the range of 10, no more than 10. Suddenly there is one that is at 100, 3 digits. So obviously, this is an odd one out. I need to revisit and check if that is a fluke or that is genuine or that is really an error. It's supposed to be 10.1. I reported as 10.103, for instance. Okay. Again, you can see a scatter plot, and you can find out that there is one that is far observed, which is unlikely, and you can find the mistakes there. Okay. Next, we are going to take a look at using statistical method to detect the outlier. So these I wouldn't go through with you. We have done this in a secondary school. In fact, quartiles, for instance, which quartile do they fall into? You know, and we also like to do averaging the bell curve. So those that fall in the range in the middle, those we are lying more onto the left hand side, the lower end, and then the upper end. So from plotting out or running simple statistical analysis, you can actually identify the outliers. Okay. Second thing that we look at about data is the missing data. Yeah, something happens, right? We gather data, there is missing data. It could be I don't have backup power supply, I don't have battery to my equipment. There's a short power cut, 10 minutes. So for 10 minutes, no data logging. All right, so the test is running, but the logger is down. 10 minutes later, when the power is up again, the data continue, the log continues to collect data. That part, the 10 minutes that the power was down, I'll find that there's a blank in my graph. So what do I do with that blank? Right? Do I have to restart the test, or can I actually interpolate, for instance, later on? So take a look at this example here. This is a data set on the people with the gender and the age pop in there. So if you look at it on the left-hand side, yeah, there are 2 things missing there. We have the gender for item number 5, Jamie. Jamie could be boy, could be girl, all right? And number 7 was I have the age, I have the gender, I don't have the name. So if I'm really not sure now, I can't go back and find them now. So I'll just omit them. So delete. All right. The second method, pertaining especially got to do with lots of data, we call the LOCF method. Is the loss observed carried forward. Meaning that what data is missing here, I use the previous data and fill in the blank. So for instance, in this case, they are collecting data of people. We have Robin, Heather, Jamie, and over time of what depending on the month, every month they have a visit. So by right, everybody should have done 6 visits here from January to June. And you find that for Robin's case, we have 3 blanks. Maybe he did not turn up in March, April, and May, or we have misplaced the data. So that last data coming in was 68. We could actually use 68 and fill in the blanks, but we note down there that this was actually LOCF. I assume that he has not gained weight over the past 2 months using the February, the latest measurement to be the input data. Okay, so similarly, you can do that for the others. Of course, the worst case scenario is missing data. I don't have it. So what? We do it. We survey, require data, we do the experiment and all. But remember, until you have exhausted the previous approaches, previous techniques, LOCF, interpolating it, or deleting the data unnecessary and still have enough data set, or don't quickly run and redo the test, all right? Because it's very, very time consuming and it can be very frustrating that. So unless it's totally necessary. All right. And the last step about the quantitative data analysis will be coding. So coding is about trying to find the pattern, all right? Right from the beginning, we talk about doing data analysis, whether it's quantitative or qualitative. The whole point is to give a meaning to it. So to get the meaning to it, we need to code it. Is it a correlation? Or is it a chart? Or is it a conclusion? Or is it some kind of checklist? Right? So depending on what is the outcome of a research. So in data coding, essentially we are trying to group and assign values to the responses from our measurement or survey. And for example, I interview 1,000 people. I need to find out what is their average age. So to do that, I'll put age bracket. Or it doesn't make sense to have 100 people. They range from age 12 to age 82. So it's ridiculous to take the whole lot and divide it by 100 and say this is my average age. It doesn't make sense, right? So, but it makes more sense to differentiate the people. Remember, qualitative data turn into quantitative. I put age brackets there. So I put them in the range of, if the age group is not too big, meaning that I know these are youth, meaning that the age is from the 16 to 20. So I put, okay, so you could be between 16 to 18, the younger ones, and then the 18 to 20 ones, the older ones, things like that. Okay, so this by categorizing your data, you could help yourself to see the pattern more easily. All right, and when we try to put meaning, all right, to our data analysis, the first level usually is descriptive here. As you can see here, I try to find variables and find pattern there. So you can see that mean, median, mode, these are all words that we find in statistical analysis. But it could be inferential. Next level, I find correlation between them, as we talked about earlier on, the regression line, whether it's the linear, non-linear relationship, and so on and so forth. Okay. And when you go on to descriptive statistics, again, is describe about the data they got in terms of their statistical analysis. Could be a mean, could be a median, could be the mode, percentage, and things like that. Again, don't memorize this when your data is out, and I'm sure you will decide on what is the best approach to discuss and present about your data there. Okay, and descriptive statistics do it. Remember that it gives you numbers, but the meaning of the numbers you have to define. It's just give you a number. So either you put them in a range or either you put them in ranking form. It's up to you. But the decision is yours. You can't just churn it out and say, if this is my statistical result, and that's it. No. You still need to decide, discuss about it. All right. Otherwise, it's meaningless. Okay. Further explanation about the statistic works there. So in terms of inferential statistics, it helps you to come to conclusion and make predictions way forward now. Remember, it has to be actionable and functional. So you extend your model to the larger population of samples or respondents, people, community, and so on and so forth. Two main uses of it. You want to make estimates, you want to make hypotheses to draw conclusions. Right? And in this analysis, we normally want to get unbiased, right? Unbiased sampling method so that the data that we collect is representative of the larger sample group. So, for instance, we want to randomly have Form 3 students to know their PT3 scores and other characteristics. So, Form 3, is it a specific school? Even the type of school, the location of school will be causing bias in our data there. All right. Can see here, sampling error. Sample is too small, sample is too big, can cause trouble there. If you look at this diagram here, interesting stuff. Probability sampling method. So in terms of probability, they're talking about every member has a chance. Everybody has a chance to be selected. To be selected means you become a representation of your group, of the larger sample. So simple random method means I just random pick. Oof, it could be anyone. Systematic means I skip in a fixed interval, one person, I skip the two, then I go to the third one, and so on and so forth. Stratified, if I pick the first one in this group, the second group, I'll take the second one, and so on and so forth. Or it's a cluster sample. I put them, this is my largest sample, it's a cluster depending on their grouping or their lifestyle preference, for instance. If it's in the inanimate object clustering, we could be talking about samples collected from the plant, manufacturing plant. We want to know the QC of it, check certain quality of my superplus, remember? So to come out 100 pieces, so I take the first three, skip the next three, and then the three, I cluster them and things like that. Or in every batch, I take the beginning, middle, and the end of the batches, and the rest I wouldn't take, and I consider them to be cluster samples. All right. In terms of non-probability kind of sampling methods, it's non-random criteria. Not everybody got a chance to be selected. For convenience sake, it could be the one, okay? The one sample, the samples I select now are directly connected to the first sample I have. So if it's the interviewee, it could look something like this. People closest to the first person that I have, right? Voluntary, now it goes wider and a bit more random. I don't know who is willing, but if I pick one, can somebody volunteer? Volunteer come along, so you can see they are going further, widening the scope. It could be purposive. I start with the one person, correct? And that one person is going to find me people for that interview, for the survey, for the experiment, in a way that is purposive, meaning that I only want master's level researcher, or I only want year one undergraduate students, for example. Or the snowball method, this is like MLM, multi-level marketing. One person find two persons find three persons, and it goes on and on. So this is pretty random as well. But the snowball sampling approach, while it is random, it may end up coming up to clusters that have certain traits, certain characteristics. This is, that's why I said, in terms of social science studies, when you deal with people, it could be pretty random and pretty unpredictable and not so under controlled conditions compared to the technical people. All right. And next, of course, we can also look at hypothesis testing. And hypothesis testing, if you have a lot of data, you could be using your statistical analysis to support or to refute your own hypothesis there. And typically, we will do this bell curve, as mentioned just now. Generally, we say we find the more the median, the more to share the same point, meaning that we have a bell curve that's symmetrical, right? Or if your graph is negatively skewed, meaning that the peak is more towards the right hand side, so it is the mode, right? The highest peak number is on the higher range compared to a positively skewed one where the mode is on the lower range. So I said, don't memorize these things. When you have your data, you may come out to patterns like this, and that graph will give you meaning. This is just a small description of it to remind us that we can encounter right graphs as such. And maybe this is more relatable to us all in terms of correlation, simple linear one. If it's going upwards to the right hand side, then we say it's a positive correlation. Going downwards to the right hand side again, that is negative correlation. scattered like this, like the twinkling stars in the night sky, no correlation. Okay, so don't force the correlation through it. Example, if I have a scattered data like this, the relationship between the weight and the height. So presumably, if I take measurements of people's weight and people's height, generally, if you are taller, you weigh more. Not necessarily true, but generally it's such. But if you weigh a lot, not necessarily you're tall, not necessarily you are short, right? So let's take a look. Say I take an average of 50 kg, right? Look, 50 kg, I move the line out. You could be 1.42, 1.4 meters tall. You could be going towards 1.5 meters tall. You could be also someone in the 1.6 meters tall range. So this is one example where I can see that a regression line may not be telling the truth of the truth. Am I not right? You can be underestimating people's weight, say 50, underestimating people's height, or you could be overestimating them. So this is quite a big scatter actually. All right. Okay. So to wrap up our discussion this afternoon, in terms of planning your research methodology, come up with your research design really, can say that a good research plan, all right, a science and technology research, right? You have clear research questions based on solid theoretical foundation. Chosen methods are carefully and suitably chosen. Data collection are done with high integrity, and your data collection and analysis are reliable, hence repeatable. You keep your data in a very, very neat way. And whatever reporting you make, whatever claim you make, you are going to be doing that based on the evidence you have got, based on your own data, based on your data analysis in comparison with other people, and based on your findings in comparison with what is reported previously. So, my dear students, you have to make sure that you keep your data organized. 1 to 2 years for a master's, 3 to 4 years for a PhD is a long time, really, to be singularly focusing on doing one thing. That's one project. So over time, you're going to get lots and lots of data coming in. But to make sure that your version control is there, you write your papers, you write your chapters, version 1, version 2, eventually you also forgotten, you would have forgotten which version you did. So it's always important, always good practice to label and name your file in a manner that is known only to you. One stroke, I don't know, or version 1, version 2, or whatsoever, put a date there, things like that. If there's a collaborative writing these days, especially, yeah, all sorts of AI tools assist you, the versions of it. You got to make sure, you want to make sure that the versions are not mixed up, so you do not like improve version 5, and when you come back and work on it after 2 weeks holiday, you go back to version 2 because you've forgotten which is which. So that's why all the more with AI coming into play, yeah, the way we manage our files, manage our data becomes more and more crucial now. Project planning, make sure you have that. You don't necessarily have to use funny softwares or even project management to do that. I don't think it's necessary. So as you know what you're doing, what you're planning, the task is there, the timeline is there, the casualty time is there, don't forget, and the milestones are there. I think it's good enough. You need not use CPM or stuff like that, to complicate life. Data storage, make sure that you have storage for that. Those days we use CD-ROMs. These days you don't even have a CD-ROM on your laptops. And then you save on hard disks. Maybe you like your own drives. Just make sure that you can save them there. They're safe. You can retrieve them anytime you like, and they are as you want them. All right. Some additional reminders if you like to do this. If your work involves a lot of lab work, it'd be good to keep a logbook, or we call a lab notebook. Meaning that I don't think it is necessary to bring a tab, because sometimes we deal with our testing and some preparation. It may not be hygienic, it may not be clean enough, or it's just impossible. If I play with soil, mixing soil in my hand, I will use my tab, right? It won't even identify my fingerprint. So that is why we may need to go back to pen and papers, bring a real actual paper notebook there, back up your data regularly. If you are having a data logger to do your work for you, collecting data, make sure you download the data and save them up in the respective folders and stuff like that, drives and all labeled correctly. And documents are being coded and named organized in a way that you know where to retrieve, how to retrieve them, and not when your supervisor asks you, last year I think we discussed, but then you don't know where the data is now. So, the more organized you are, then the easier. The easier your life will be when you eventually come to compiling and writing up the thesis. And of course, keep time. You plan your Gantt chart, you put in the milestones, you are the one who is following through with the work. Your advisors are just there to guide you, to give advice, not to lecture you anymore. You decide on the direction and the pace of your work. So make sure that keep time so that we do not get stressed out at the end of things. All right. In summary, a research that what you're undertaking now, my dear students, is that you don't know, but you're willing to find out. All right? You don't know. We don't know. That's why we are researching. So let the adventure begin. I wish you all the best. First and foremost, sort out your assignment 3. It's a quick and simple one. I try to keep it as simple and as easy as possible so it doesn't take up too much of your time, because I believe as a responsible research student, you would have started your research by now, in one way or another, right? The least you could have done is that you are doing literature review now. So even though you have not come to the lab or things like that, or you have not started collecting data or look at your test equipment and so on and so forth, but the least you could do in week 5 this semester, at least if you have registered in week 1, is that you are having your proposal, or rather the research plan first, the skeleton of it, being built up now, and not waiting for something to happen or something to drop from the sky. I'm not sure. All right, so that is all I had to share with you. Good time, 4:30. Is there any questions? Anything you want to ask me?
Prof, can I ask a question?
Sure.
Okay, for yesterday's assignment, is it a must for me to design an engineering topic?
No, any topic will do. It's just
Because-
that this research methodology class is for science and technology. So I understand that most students will be, or rather, most students will be doing quantitative, I believe.
Because in the pamphlet, the objective here is only mention engineering topic at the objective.
Is it?
Yes, that's why I'm having problem understanding this assignment. Students apply the concept of research methodology to a real engineering topic. That's literally the sentence stated in the objective.
You are from which faculty?
Huh? What?
Which faculty are you from?
I'm from FAS.
What is your research topic about?
My research topic about wait. My research topic is optimization of precision fertigation and split phase NPK requirement for Librica coffee rootstock and selected clones under different fertilizer regimes.
Is it a scientific research?
Yes, it's a scientific research, but it's not an engineering topic.
Yeah, so forgive me for the term engineering. So any scientific research then.
Okay. Because I'm quite worried because I don't have any basics in engineering.
No, don't take it literally. What's your name?
My name is Ahmad Arif.
Arif, you are doing a PhD or master's?
PhD.
At PhD level, at
Yes.
one point or another, you got to learn to make judgment based on the information you have. So for example, in this case, I say, you say you want an engineering project. And obviously you're not from engineering background. In fact, half the students here are not from engineering background. So it's just, if you look at the requirements of that, or the instructions of that assignment, it applies to any research project, isn't it? Any research project would have followed through the same structure. It's okay, I will make sure I change that. Oh, in fact, I changed that, but the one uploaded is the old version.
Yeah. Okay, so sorry for the misinformation,
No, it's all right.
Professor.
Good to point out. All right. Thank you for that.
Because
Any other
the objective,
question?
the students
Mm.
apply the concept research methodology to a real engineering topic at the objective section.
Okay. Is it clarified now? Is the video explanation good? I had to refine it 3 times. And I thought that is the best they could do. But no, but is it good? Is it clear on what you guys have to do? Okay.
Doctor, can I
Any other
ask?
question? Yeah.
Uh, is there any format to do this assignment, or we just
No format. As I mentioned earlier, actually, Sahida, yeah, that is freestyle. That's why I say 2 pages, but if you could make it 1 page, 1 page. As long as you fulfill the rubric, you can score. That's it. Super.
all right?
It can be an infographic. It can be in Word format. It can be a poster, whatever you like. That's it. This is supposed to be non-stressful exercise. Yes, as long as you do it, and ideally it's for your own project so that it can at least get a general idea, a basic idea of what your research plan is going to be like. Correct.
Prof,
Mm.
one final question. If I come from a research institute, I just use the template provided by my research institute to complete your assignment. Is it okay?
I don't mind any format, but I mind if I cannot find the answers to answer the rubric.
To
Because
answer the answer.
because I'm using the rubric as your assessment tool. So you got to help me to find the answers there. So if I cannot find the answer, how can I give you the mark? That's the whole point of having the rubric. So it's like this, my dear students. The rubric was created to help you to score. So the rubric shouldn't be a burden to you. Simply put, put it this way. Do your proposal or do your research design and then put it to ChatGPT, Notebook LM, maybe the more advanced version, the paid version perhaps, and tell them you want it to fulfill this rubric. Then maybe that will be helpful. Understand what I'm saying? Otherwise, everybody be submitting a very, very different style and different format kind of thing. And the marking will be unreliable and not valid because I'm going to be like, oh, for different kind of submission, every submission I weigh it differently, I judge it differently. So where is the yardstick now? There's no ruler. We can't do that. Hence, we need the rubric, and hence when there's a rubric, there's a ruler. Everyone must be working according to that ruler. Understand what I'm saying? And I think we have to stop asking for documents when we can't access author. So the first thing is access author. Everyone needs to be registered. Hence, you can access author. So before we start jumping the gun and panicking, shooting panicky questions in the WhatsApp group, let's maybe check with our friends first and make sure that we are not left behind, or we are not quite following the correct record system or registration system. You get what I mean? I believe that CGS has uploaded all the necessary documents in the author for your usage, for your reference. My view. Remember, you are postgraduate students, postgraduate. I repeat, postgraduate, meaning that you have graduated with the necessary degree respectively. For those who are doing a PhD at the highest level of degree in the academic world. So we have to exercise a certain level of logical and mature judgment before we jump the gun. Otherwise, we are not upping our game. We are performing, behaving just like when we were at undergraduate. Then we are not behaving like a postgraduate research student. In fact, I omit student, I say research scholar. Understand? Next level dah. So got to behave and carry yourself, conduct yourself at the next level. Do not panic easily and follow the instructions, read the instructions, follow instructions, use your judgment to bring your work forward. Right, any other question?
No, no question, Doctor.
No question. Clear on what to do, yeah? Okay, no question about the assignment. Any questions about research in general? Yes, be of time in case I can answer you. Something you want to ask. If I could answer, I would try to answer it. Anything? Nope. Either my sharing has been crystal clear, or you have fallen asleep, or you're super boring. But never mind, before we go, if you could just take a look at the very important reminder down there. I make sure this goes into the recording as well. Please, no more than 2 pages. If you can make it one page now. Okay? And save your file as PDF, regardless of what format it is. In the end, please make it as a PDF and save your file following the format as shown here. Your name as you register, caps your surname, right? Caps your surname. So, for instance, Ismail bin Sidin. So, bin Sidin is your surname, right? And followed by, in brackets, your metric number. Okay, underscore M3. So we know this is for module 3. Please, it seems a very simple instructions. You'll be surprised at how people ignore or don't understand this instruction. Just last year, when we had this class, last semester rather, I don't think anyone followed these formats. All sorts came in. And it was nightmare for us, the markers, to identify whose submission this is and for what module. So please, I believe it's the simple instruction. And I repeat myself there, start early and finish early, submit early when it's done. So it's out of the way. You can focus on other things. I'm sure you got other better things to do. And the due date is 3 weeks away. Yeah, it's on the 1st. When this thing can be done, I believe in 1 hour it should be done. So there's no reason to ask for extension. There is really no reason I can foresee to have forgotten or missed the boat. And then 2 months later, when the grades are out, why is it I get 0 for M3? Or I submitted, you didn't mark, and I show proof that I submitted, you didn't see. Let me put it this way. On the 1st of May, at 12:01 p.m., I would have stopped marking. Can I put it this way to you? Yeah. It's like we submit a tender document. The deadline is 12 p.m. 1st of May. 12:01. If I were to bring my tender document and submit in the box will be no longer there. Am I not right? Exams, 3 hours. Starts at 9, finish at 12. 12 p.m. if I don't drop my pen, the invigilator can refuse to collect my paper because I cheated. I used more than 3 hours. You get what I mean? So we are at postgraduate level, the highest level of the academic qualifications. We should behave responsibly. Okay? So please, on the 1st of May, I really don't see any reason why that cannot be done. But in case really there's a reason, for whatever reason, I don't know, breakdown of my machine, I fall sick, and so on and so forth, then yeah, maybe. But let's hope not. We start early, then whatever mishap that may happen, then it won't happen. Think of it this way. If you have a flight to catch, a long time plan holiday, going to London, next week, next Thursday, 11 p.m., KLIA. Would you miss that? I doubt. All right. So let's take our work seriously, lah. Okay. I put in the attendance link in your chat box there. Is it there? Can you see? Is it there? Yes? No? Don't like? Yep. Okay, so if nothing else, I wish you all the best. Bukan nak bebel, reminder 1st of May, but do it early and submit aja, finish it aja once and for all. You have my contact details if you need to contact me. If you WhatsApp me, tell me who you are. Otherwise, many people texting you don't know who they are. So just tell who you are, which program, and that what is the question. All right. So I wish you all the best. Take good care of yourself. Don't stress. That's the word. Work-life balance. Keep playing your paddleball or we call in Indonesia, we call it paddle game, we call it kickball, right? Or whatsoever that is. So yeah, I see you around. Bye. Salam.